In this section, we'll have a look into reactive programming and how we can make use of the concepts of reactive programming to build resilient, scalable, and responsive microservices. This video will talk about reactive programming in general and the essential characteristics of reactive systems, including responsiveness, resiliency, elasticity, and being message-driven. We'll see how to use the principles of reactive programming to build message-driven, highly scalable, and available microservices. Reactive programming is a programming paradigm oriented around data flows and the propagation of change. In simple words, in reactive programming, data flows emitted by one component will propagate to another components. Those are registered to receive these changes using an underlying message structure. Reactive applications are built on four guiding principles. The goal of reactive programming is to build a responsive application. A responsive application is both scalable and resilient. Responsiveness is impossible to achieve without being scalable and resilient. A message-driven architecture is the foundation of a scalable, resilient, and ultimately responsive systems. Now, let's explore each of these principles at a high level to understand why all of them must be applied together in order to develop quality software in a modern context. Traditionally, concurrent systems were composed of multiple threads communicating with shared and synchronized state. This kind of communication often led to very high degree of coupling, and also such systems were hard to compose. Message-driven systems, by contrast, are composed by loosely coupled event or message handler. Messages or event in such a system can be handled asynchronously. They do not incur any blocking, and because there is no blocking, that means typically resources can be utilized much more efficiently. An application is scalable if it's able to be expanded according to its usage, and typically we distinguish two directions of scaling. They scale up, which means they can make use of parallelism in multi-core systems, which become more and more common in computers today, and that is scaling out, which means we can make use of multiple server nodes in a data center or in a cloud. Important for scalability here is always to minimize shared state and property of location transparency. The other important property for scaling is resilience, because once you have multiple nodes, some of these can fail, and the system has to cope with that. An application is resilient if it can quickly recover from failures. Such failures should be software failures, such as throwing an exception, or hardware failure, a computer going down, or maybe connection failures or internet connection going down. Both cases, the user should not be affected and should be able to perform his activities normally. Finally, an application is responsive if it provides a rich real-time interaction with its users even when under load and in the presence of failures. Response of applications can be built on an event-driven, scalable, and resilient architecture.